Session 8, Local Area Network Infrastructure, LAN. If you see, yesterday it was the basics, more of basic introduction, foundations and everything. But today we are getting into detail. So this is session 8, Local Area Network Infrastructure. Agenda of the session is bridges and switches. We discussed, I gave you introduction yesterday. IP routing topology, static IP routing, dynamic IP routing, and controlling data movement with filters and virtual LANs. So by the end of the session, you will have good theoretical understanding of bridges, switches, routing, static routing, dynamic routing, and all that. Local area communication networks. Local area is basically spread or covers a building or campus less than 2 kilometer radius. Simple topology like the bus topology, ring topology, or star topology. Dedicated cables as transmission media are used. Data rate is not fast, it is 1 to 100 Mbps or from this point to 1 Gbps. Low error rate compared to wide area network and interconnected LANs to WAN. LAN protocol standards are defined by IEEE 802 committees. Basic function of LAN: it supports for exchanging packets between computers on the LANs, therefore provide data link layer services only. Bridges offer the ability to expand beyond single LAN, meaning simple, two different kind of network, one and then another, and we need to connect two, so we need to distinguished or diversified kind of network we connect through the bridge. Use bridge or router. Bridge is simple or simpler which connects similar LANs, identify protocols of physical and link layer, and minimal processing. Routers are more general and they are general purpose. They can interconnect various LANs and WANs. So the difference is quite simple here. Bridge connects same type of LANs, similar LANs. Router can connect different LANs and WANs. Why we need bridge? Because of reliability, because of performance, because of security, and because of geographic requirement. Functions of bridge: it read all frames transmitted on one LAN and accept those addresses to any station on the other LAN. Using MAC protocol or second LAN, retransmit each frame. Do the same for other way around as well. So bridge operations is like this: LAN A, LAN B. To connect these two, we use bridge. So it frames with the address 11 through 20 are accepted and repeated on LAN B. Similarly, frame with address 1 through 10 are accepted and repeated for LAN A. That's how the bridge works. Hub and switches. Shared medium hub and switched LAN hub. What is shared medium hub? It is a central hub. Hub retransmits incoming signal to all outgoing lines. Only one station can transmit at a time. With a 10 Mbps LAN, total capacity is 10 Mbps only because multiple clients or nodes cannot transmit at the same time. Only one can transmit at a time. Switched LAN act as a switch. Incoming frames switches to appropriate outgoing line. Unused lines can also be used to switch other traffic. With two pairs of lines in use, overall capacity is now 20 Mbps. Switched hub. No change to software or hardware of device. Each device has a dedicated capacity, so therefore they scales very well. Store and forward switch, accept input, buffer it briefly, and then send it to output. We also have cut through switches. Take advantage of the destination address being at the start of the frame. Begin repeating incoming frame into output line as soon as the address recognized. So may propagate some bad frames also because of this reason. Ethernet bridge and switch. Bridge deals with both physical and data link layers. It can relay frames or packets between two segments of same type of length by using address mapping table. It does not modify the content of packets. Like we have these are bridge. This is connecting two different LANs. IP routing topology. IP routing topology. There are two basic methods of building a routing table: static routing and dynamic routing. Static routing. Static routing is table is created, maintained, and updated by a network administrator manually. A static route to every network must be configured on every router for full connectivity. This provides a granular level of control over routing, but quickly becomes impractical on large networks. Routers will not share static routes with each other, therefore it reduces CPU or RAM overhead and saving the bandwidth. However, static routing is not fault tolerant, as any change to the routing infrastructure require manual intervention. Routes operating in purely static environment cannot seamlessly choose a better route if the link becomes unavailable, because static, as I said, static routes have an administrative distance, that is AD, of 1, and thus are always preferred over dynamic routes unless the default AD is changed. The static routes with an adjusted AD is called floating static routes. Dynamic routing table. A dynamic routing table is created, maintained, and updated by a routing protocol running on the router. Examples of routing protocols include RIP, that is Routing Information Protocol, EIGRP, that is Enhanced Interior Gateway Routing Protocol, and OSPF, that is Open Shortest Path First Routing. Dynamic routing table. Routers do share dynamic routing information with each other, with which increases CPU, RAM, and bandwidth uses. However, routing protocols are capable of dynamically choosing a different or better path when there is a change to the routing infrastructure. Routing versus routed. Do not confuse routing protocol with routed protocol. A routed protocol is a layer 3 protocol that applies logical addresses to devices and routes data between networks such as IP. Whereas routing protocol dynamically builds the network topology and next hop information in the routing table such as RIP, EIGRP, etc. Advantages of static routing: minimal CPU or shared memory overhead, no bandwidth overhead, updates are not shared between routers, and granular control on how traffic is routed because it is done by administrator. Disadvantages of static routing: infrastructure changes must be manually adjusted. No dynamic fault tolerance if link goes down, and impractical on large network. Advantages of dynamic routing: simpler to configure on larger networks, will dynamically choose a different or better route if a link goes down. Ability load balance between multiple links. These are advantages of dynamic routing. Dynamic routing also has its own disadvantages. Updates are shared between routes, thus consuming a bandwidth. Routing protocols put additional load on router CPU or RAM. The choice of the best route is in the hands of the routing protocol and not the network administrator. Dynamic routing categories. There are two distinct categories of dynamic routing protocols: distant distance vector protocols and link state protocols. Examples of distance vector protocol include RIP and IGRP. Example of state protocol include OSPF and ISIS. EIGRP exhibit both distance vector and link state characteristics and is considered a hybrid protocol. Distance vector routing protocol. All distance vector routing protocols shared several key characteristics. Periodic update of the full routing table are sent to routing neighbors. Distance vector protocols suffer from slow convergence and are highly susceptible to loops. Some form of distance is used to calculate a route metric. The Bellman-Ford algorithm is used to determine the shortest path. Link static routing protocol. The link state routing protocol were developed to alleviate the convergence and loop issue of distance vector protocols. Link state protocol maintain three separate tables: neighbor table, topology table, and shortest path table. Neighbor table contains list of all neighbors and the interface each neighbor is connected off. Neighbors are formed by sending hello packets. Topology table, otherwise known as link state table. It contains a map of all links within an area including each link's status. The shortest path table contains the best routes to each particular destination, otherwise known as routing table. Segmentation. Network segmentation with virtual local area network (VLAN) creates a collection of isolated network within the data center. Each network is a separate broadcast domain. When properly configured, VLAN segmentation severely hinders access to system attack surfaces. It reduces packet sniffing capabilities and increases threat agents' effort. Finally, authorized users only see the servers and other devices necessary to perform their daily tasks. Data movement with filters and VLANs. This concept is often referred to as protocol filtering or network whitelisting because it defines the network behaviors that are allowed and filters the rest, essentially limiting the network to specific protocol session and applications use. This can be enforced generally only Profinet is allowed, or every granular Profinet is allowed only between these specific devices using only explicitly defined commands. This level of control usually requires the use of network-based IPS or next generation firewall, that is NGFW, that is able to inspect the filter traffic up to the application layer. The VLAN segmentation is common on networks where performance is critical as it imposes minimal performance overhead and is relatively easy to manage. It should be noted that VLANs are not a security control. VLANs can be circumvented and can allow an attacker to pivot into the network segments. More sophisticated control should be considered in areas where security is more important than network performance. That's all for this session. Thank you.